Good afternoon, Dr. Hassan. This is my presentation of my project 2 in system dynamics. I'm in section 062. My name is Chijiyoke Obodoekwe. This project is we're working on a project about turning suspensions for bikes. Bikes that we all know have 2 tires, and at the back we have 2 kinds of shocks at the back tire, while in the front we have the fork that is holding it. On one side of the fork we have a spring, and on the other side of the fork we have a damper. The damper and the spring work side by side. The damper regulates the spring. The spring also controls the damper. One way or the other, they move together for a proper and smooth movement of the biker while the biker is on the bike. Also, in this project, we'll be considering the mass of the rider, the surface on which the bike is going to move. The surface could either be smooth or rough. But whenever I mention a surface in this presentation, I'm referring to wherever it's moved, wherever the bike is being rode upon. Okay, and on a general note, we all know that system dynamics has been something that's evolved over time in the engineering world. System dynamics has been something that has been has played a very important role. That a lot of things have been modeled when it comes to system dynamics. It can be used in the oil and gas industry, it can be used in the automobile industry, it could be used in the fluid industry, in the refineries, just name it. But for the sake of this project, we are narrowing down simply to the mechanical part of it, which is about the spring and the damper. Now, suspension turning in bikes is about controlling the oscillation of the spring damper system, which is a well-studied problem when it comes to the engineering world. Because we believe that in engineering, solving a problem is the beginning of something, and ability to control this spring damper suspension in bikes has actually come a long way. By spring damper theory, we also have to compare 2 bikes in this situation: the one that has a spring damper together with it, while the one that doesn't have it. You realize that the one that has a spring damper on it has a better suspension, has a better movement on it, has a better oscillation, has a better balance, and also for safety purposes. This provides us the path for us to understand that this thing about spring dampers on bikes has been what has evolved over time. And it has also made people to actually have interest in it, which actually drew my curiosity about it. Since we know that bikes has been what has been in existence for a long time, and for us to be able to get more safety features on it, we need to develop more on this spring and the damper part of it. Because the more stable the spring and the damper is on these bikes, the more safety measures that is being applied on it for the rider himself. Now, the application of this project, we're going to have this project is about the shock suspension at the back, the bicycle suspension system, which is in the front, and also the recoil systems. The works that have been done before, I will be referencing some other bike producers. People like Harley Davidson, they make bikes. Okay, people like BMX, they make bicycles. Now, these people have been able to design some things to work on this. And over time, there have been some developments, because every year new bikes are being released, and for every new bike that's been released, there's a modernization of something in the damper and in the spring part of it for safety reasons. Now, this project plan is for us to have a mathematical model designed in such a way that any form of spring damper that is being brought forward, when we plug in the variables involved in it, it should be able to spew out the information that we need from the mathematical model that we're going to design. The mathematical model will have to have the mass variable, to have the spring variable, which is the K, which also have the damper variable, which is the B, and we also have the distance and changing length or changing variation as the bike moves on the surface where it is being rode. The mathematical model of suspension has other variables attached to it. We also have to remember that the kinetic and potential energies involved in this, the damper forces involved in this, the Laplace transform which will be used to design the mathematical model is involved. We will also create a block model diagram, and also have an analytical analysis. Now, if you're looking at my PowerPoint presentation, you will see the schematic drawing of what the spring and damper system looks like. Now, the M represents the mass of the rider, the K the spring constants, like I said earlier on. The Y also represents the motion of the body and the output, the vertical motion of the body and the output on when the biker is upon the bike. We'll also design an equation which will be used for us to quickly analyze and for us to quickly understand what this is all about. And for our final results on this is for us to be able to create something that will be easy for anybody who comes around and looks at it. They should understand that this is the model for the spring and damper system. And also, whoever wants to do anything or modernize the spring and damper system just needs to get the equation, put it into a MATLAB and run the simulation after plugging in the variables that is being needed for us to get a better response. I hope with this presentation you'll be able to understand what I'm talking about when it comes to the spring and the damper system. Thank you very, very much.